Here we are at the end of Unit 1 of our Engineering and Technology. So today I'm going to do a quick review with you of this unit. As we go through this, you'll have to answer questions along the way. Let's get started. So we've looked at this rocket. It had to be tested. We had some vocabulary. We've talked about constraints, and those are limits on a solution. Usually it's time, money, materials. It's something safety needs. It's things that cannot be changed. It has to meet those. Criteria is the desirable features of a solution, what we would like for it to do. It doesn't have to meet all the criteria, but it has to meet all the constraints. Engineering itself is the process of designing new or improved technology. A failure analysis is figuring out what went wrong with a solution and why. We use that to help fix our solution to make a better solution. A fair test, and that's a test that does not give any advantage to the conditions or objects being tested. Everybody gets the same conditions. Optimize, to make a solution as good as possible. Our first lesson was talking all about problems and how engineers define them. So this introduced the unit project, which is a hearing enhancing device. Our first exploration in that lesson was what is technology, and technology is how humans change the natural world to meet a want or need. Technology is constantly changing. Engineering is the process of designing new or improved technology. Think about like cell phones, for instance, or gaming systems. They're always coming out with new and improved cell phones and gaming systems. So that's an improvement on the technology that was in the previous one, because we always want things that have more bells and whistles. They have better things to offer us. They have better graphics. They may take better pictures. They have better sound quality. So in order for you to make the solutions as an engineer, you've got to know what the problem is, okay? So in this picture, we have some everyday kitchen objects, and those are improvements to a want or need. The refrigerator, we need to keep our food cold so that it doesn't spoil or rot. Well, that is an improvement, and it meets the need. We have a microwave. The need is to fix food quickly, to eat, and it does it quicker than a stove. All right, that's just a couple examples. You had to look around and see things that were engineered and not engineered. Things that would not be engineered would probably be things that occur in nature. Even our desk in our classroom are engineered. They are made. So we talked about technology items and how they meet wants or needs. Again, criteria are the desirable features of solution. We're talking about, we know that rags, like cloth rags, can soak up liquids. But a paper towel is an improvement on a rag because paper towels meet a new criterion. They can be thrown away, whereas a rag made of cotton material, you wouldn't want to throw that away. You want to wash it and reuse it. Okay, we didn't do the menu planning. Let's keep on going. Real world limits. So, again, limits. We're talking about constraints, and those include money, time, and materials. Some safety constraints are by law. So those you definitely have to meet those constraints. So we looked at the bicycle. The helmet is for safety. We have brakes. We have gears on the bike. We have wheels. There's all kinds of things here that have constraints on them. Moving on down. This was also about the bike, the 10-10-10. All right, we talked about the laundry baskets and how they improve solutions all the time, but they may not work for everybody. Some people may have constraints such as how much money that these cost or how much room that you have to put them there. So that's how you would decide which one to use. All right, here's where you're going to answer your first question. So the question is, identify the constraint for a new pair of shoes. Comfortable, resist water, attractive, costs less than $35. Here's our next question. Identify the constraint for a homework assignment. Neatly written, shows originality, completed by tomorrow's class, correct grammar. Okay, we didn't do the discover more. We're just going to hit and pick some questions here in the lesson check for you to do. Let's go on down. Oop. So, it says choose all the statements that are correct. Solutions meet a want or need. Solutions are separate from engineering. Solutions are the technology all around us. Solutions come in different forms because they help solve problems. And the last one, solutions must be complicated in order to work. All right. All right. Identify all the likely constraints when faced when designing and building a treehouse. Constraints. So remember, we're looking at constraints: time, budget, materials, sunlight, tree size, number of tree branches. Okay. So here we're going to move on down. I'm going to go through these really quick with you. Engineering, that is using technology to design solutions to solve problems. Constraints, those are the limits on a solution. Criteria, the desired features of a solution. And problem is the indication of a want or a need. All right, moving on. Let's look at the lesson roundup for lesson 1. Let's see. All right, so we're going to do this question. What you're going to do is pick the choice that has the words in the correct order. Engineering problems, wants, or limitations have criteria and constraints. The criteria describe a need or solution, want, or idea. The constraints describe the wants, limits, or criteria for the engineering solution. All right, lesson 2. We're talking about the solutions now. We talked about birds. When we're trying to figure out the solution, after we know what the problem is, we need to start doing some research. Before we can come up with a solution, we've got to know a little background information. We were talking about our hearing enhancing device, so we talked about different types of ears that animals have and how that it helps them to hear. Then we discussed what the shape of the ear, and then we determined how those ears are the same and how they're different, and how that it can help you design your hearing enhancing device. So, here we had some audio of birds, and now let's move on to exploration 2. Past hearing helpers. So in our research, we want to look at previous designs that have met that criteria in the past, that have been used, and by looking at those, it can help us design a new one to make it new and improved. So we're talking about hearing enhancing devices. So now we had these 4 different hearing devices, and how their shape and how they've changed through time. All right. Okie dokie. So it says, how does studying others' hearing enhancing solutions help you with your possible design? It gives you ideas of even where to start. You may be clueless and don't know what you need to do first, but if you look at somebody else's, it may help you to come up with your own design. Looking at the ears of the animals also will help too. Exploration T, after we have decided on a solution, we've got some ideas. Now we've decided, we've done research, we're deciding on a solution. We're going to have to start testing prototypes. So here we talked about having conditions that would be suitable to test headphones, microphones, and speakers in an anechoic chamber. We also talked about aquadynamic testing facilities that's similar to a wind tunnel. They use it to test vehicles and objects to make sure they're safe and don't leak. So this is much better than doing it in a wind tunnel. Okay. Fair test. We said that fair test, they don't give any advantage to conditions or objects being tested. They observe and measure the effects of changing only one thing, and we call that thing a variable at a time. We're not going to change a whole lot of things because if it suddenly works better, we're not going to know exactly which part made it work better. Even though it sounds quicker to change a lot of things at the same time, there's no way to know which one would cause the results. So here's an example of a fair test. You want to find the fastest walk home. You need to take time each route, so we have different routes, and you need to walk at roughly the same speed on similar days. You're not going to you're going to go different routes, sorry. You're not going to run one route, walk the other, and skip the third way. You're going to walk at the same speed, the same pace, and you're going to make sure that you don't have any extra added on weight. Make sure that you have on the same type of shoes. And it's also the same with the weather conditions. Okay. Let's go on down. All right. We did not do the design it. So now we're doing, well, let's look at the self-check on this lesson. It's loading slow, I'm sorry. So on this one, you're going to pick the word combinations. This word will be first. This one will be second for the answer. Engineers design blank acoustic solutions or problems to meet people's wants and needs. They perform solutions, fair test, or old prototypes to help them to design new devices. We're going to move past that question. It says select all the choices that correctly complete the sentence. Engineers, A, test solutions to design problems more than once. B, don't waste time learning about other solutions to their problems. C, don't try to improve other solutions or their own solutions. Or D, create more than one solution to the same problem. Remember, this is select all that apply, so there's probably more than one correct answer. All right, so let's move on. Okay. We're not going to worry about these questions today. All right. And our final lesson in this unit was how do engineers test and improve prototypes? So we talked about how with every rocket design, they have failed ones, so they have to do tests first, because if they failed, they wouldn't want to have any people or animals or objects on board that are not replaceable. So they test them to make sure that they work correctly. Okay, things fail and improve. In engineering, it is okay to fail. Failure is okay, because failure allows us to learn and to become better. So, a lot of times the designs that engineers come up with improve bit by bit as they learn more about what they're actually using. Again, they're going to do small positive changes that build up as engineers test and add them to design. By the time they are finished, they have the ideal or best design possible that meets all the constraints: time, materials, budget, perhaps safety too. All right, we talked about failure analysis and brought up one of my favorite shows, Nailed It, where people have to go into a show and they're trying to recreate cakes that are beautifully decorated and taste delicious, or cookies. And gosh, love them. They don't have the time or the ability to do them correctly. So they usually are huge flops. They're big failures. All right. So when they do that, they try to figure out what went wrong and why. Again, this talks about testing one system part at a time. That way they can zero in on the ideal solution for the criteria. Here it's talking about baking cakes. And we had to look at these different cakes and decide how much baking powder and how long to cook it for to get the best cake. All right, we're going to do this one. You're going to have 3 words in your choices, and you need one that has the words in the correct order. Most prototypes are blank, perfect, imperfect, easy to redesign. When testing a design solution, it is critical to go through a failure analysis, success analysis, or variable analysis. This helps blank a solution. This helps detect a solution, improve a solution, or vary a solution. All right, moving on to exploration 2, getting better. This lesson was all about collaboration and communication, working with other people. I've always heard the expression 2 heads are better than one. It's good to have somebody else to bounce ideas off of. They may tell you, hey, that's a great idea, or I don't know if that'll work, but maybe you should try this. Maybe this would be better. What if you did it this way? Okay. When we discuss things and communicate, we optimize or make as good as possible. So we're coming up with the best possible solution. We are optimizing our solution. So good communication and teamwork help improve any team's final result. Doesn't matter if it's an engineering team, a volleyball team, baseball team, academic team, marching band, whatever you're into. All right. Let's keep on rolling. All right. We did not do the discover more. So let's look at the lesson check. We're not going to do that. We're going to skip that one and that one. I don't like that one either. All right. Okay. Feedback is important in solving any problem. How can you give good feedback? Choose the best answer. A says tell the other person that his or her project is a good example of what not to do. B says tell a person that his or her design is poorly built. Do not suggest any improvements. C, Tell the person that his or her design is built well, but still suggest some possible improvements. D says ignore the person if he or she isn't listening to you. So go ahead and answer that question. Let's go on to the lesson roundup. Let's answer this question. Which of these describes a good approach to solving an engineering problem? Select the best answer. Research, revise, and repeat. B says, give up if your first solution fails so that you don't waste any more of your time. C says, failure marks the end of the process. Or D, if at first you don't succeed, try again. Moving on. Can an engineering design solution that does not pass testing be considered useful? Select the best answer. A says no, a failed test shows that the design solution is bad and will never work. B says no, you can only rely on a design solution if it passes every test that you use for it. C says yes, failing one test is acceptable. If it fails again, the idea must be dropped. D says yes. Learning what doesn't work is just as important as seeing what does work in a design solution. All right. Moving on. All right. Let's look at the review. Which statements are true of the object shown here? Select all that apply. A, it meets a want or need. B, it can be found in nature. C, it meets no specified criteria. D, it was designed by engineers. E, it is an example of technology. Number 2, which pair of factors defines any engineering problem? Select the correct choice. A, wants and needs. B, time and expense. C, nature and technology. Or D, criteria and constraints. Number 3, you're going to pick the 2 words in the correct order. A set of criteria, a list of constraints, or a budget states the desirable features of a solution. Limits on solving a problem are called criteria, materials, or constraints. All right, we're going to skip through that. We're going to skip that one. All right, here you're going to pick the 2 words in the correct order. Testing a prototype works best when the engineer observes and measures the effects of changing a single thing, several things at once, their designs, their criteria. Engineers test and retest to change failure points or improve. Now, the next question, what makes crash test dummies useful substitutes for human beings? Select the correct choice. A, they are able to avoid collisions. They have been used since the 1950s. They contain sensors that collect data. They are smaller than average humans. All right, here we go. An engineer can find things needing improvements by isolating failure points, results, prototypes, or working solutions, or design difficulties. So you have quite a few to choose from there. That term refers to failure points, results, prototypes. Well, that's not what I meant to do. Working solutions, or design difficulties. So let me read those again. Failure points, results, prototypes, working solutions, and design difficulties. The next one, select the best answers to complete the sentences below. Collaboration, failure, research, a prototype, or brainstorming gets you a lot of ideas quickly. However, we say that collaboration, failure, research, prototype, or brainstorming leads to optimization because sharing successes often helps make the best engineering solution. All right. That is the end of our Unit 1 review. Make sure that you answer all of these questions in the Ed Puzzle. If you have any questions, please let me know.